students, as we have discussed, the vector equation of a plane passing through the point A bar perpendicular to unit vector n cap, it's just recollecting the concepts, is what? R bar minus A bar dot n cap is equal to 0. This is the vector equation of a plane passing through the point A bar and perpendicular to unit vector n cap. Later, we have expanded R bar dot n cap minus A bar dot n cap is equal to 0. So therefore, R bar dot n cap is equal to A bar dot n cap. This is, now since the vector equation of plane where P be the perpendicular distance from the origin, P be the perpendicular distance from the origin to the plane, and n cap be the unit vector perpendicular to it, then R bar dot n cap is equal to P. Therefore, I can write this is P is equal to, that is A bar dot n cap. P is equal to A bar dot n cap. This represents the perpendicular distance from the origin to the plane which is passing through the point A bar and perpendicular to the unit vector n cap. Yes, let us see. Now this is a vector equation. I want note or a result of it. Let A bar is equal to A1i, A2j, A3k. Next, n cap is equal to L1i, L that is M1j plus LMJ nk, and R bar is equal to xi plus yj plus zk. These are the vectors. So therefore, I can write, I want the Cartesian equation. Cartesian equation of a plane. Cartesian equation of a plane passing through the point A bar and perpendicular to the unit vector n cap is R bar minus A bar dot n cap is equal to 0, which implies R bar dot n cap is equal to A bar dot n cap. What I did is take the dot product. If I take the dot product, R bar minus R bar dot n cap is equal to A bar dot n cap. So therefore, now what is R bar? Xi. So which implies xi plus yj plus zk dot n cap, where LMN or the DCS, of a line or a vector. You know already L square plus M square plus N square is equal to 1. So therefore, whenever you come across L square plus M square plus N square, you are liable to write 1. So therefore, now take the dot product. R bar dot n cap, this is Li plus Mj, this is Nk. Li plus Mj plus Nk is equal to A bar dot n cap. This becomes A1i plus A2j plus A3k, right? Dot of it is x minus, I can write into, it is Li plus mj plus nk, right? So therefore, I can write this one as that is Lx plus My plus Nz is equal to Al plus Bm plus Cn is the what? The Cartesian equation of a plane. Before that, I want to press the what? One point into what context? What is that? That is I dot I is equal to 1, I dot j 0, I dot k 0, next I dot I 0, I dot I 1, I dot j 0, I dot k 0. Similarly, you have to go with what? Dot product, taking with each and every component vector with j as well as k. So therefore, Lx plus My plus Nz is equal to what? La plus Mb plus what? Cn. La plus Mb plus Cn. This represents the Cartesian equation of a plane. Cartesian equation of a plane. You take this P. What is this P? P is equal to Al plus Bm plus Cn. The Cartesian equation of a plane passing through the point A bar and perpendicular to the unit vector what? N cap. So therefore, yes, students, we have come across in detail regarding the vector equation of a plane passing through the point A bar and perpendicular to the what? Unit vector n cap as r bar minus a bar dot n cap is equal to 0. Meanwhile, the Cartesian equation of a plane passing through the point A bar is equal to a1i plus a2j plus a3k and perpendicular to the unit vector n cap can be taken as Li plus Mj plus Nk, where L, M, N are the DCS of a line or a vector, and meanwhile R bar is equal to Xi plus Yj plus what? Zk is given to be R bar minus A bar dot N cap is equal to 0, R bar dot N cap is equal to 0, A bar dot N cap is equal to 0, R bar is equal to Xi plus Yj plus Zk dot, that is Li plus Mj plus Nk. So therefore, A1i plus A2j plus A3k, Li plus Mj, take just a dot product that gives the Cartesian equation of a plane passing through it. Yes, let us have a discussion about what is the equation of a plane parallel to it, may be taken in terms of vector, may be taken in terms of what? Cartesian. Okay, let us see. Now look here. Note the vector equation of a plane parallel to R bar dot A bar is equal to P is R bar dot A bar is equal to P is R bar dot A is equal to Q. Right? R bar dot A bar is equal to P is what? R bar dot A bar is equal to Q. If I take in terms of second one, Cartesian equation of a plane parallel to X plus by plus cz plus d is equal to 0 is ax plus by plus cz plus d1 is equal to 0. They differ by a constant. Here also the constant is p. I have taken as what? P. Followed? Right. Next, the Cartesian equation of a plane, the vector equation of plane plane parallel to r bar minus a bar dot b bar is equal to 0 and passing through the point C bar and perpendicular to B bar is right. So therefore, similarly, you can go for what? The Cartesian equation of a plane. Now let us see the angle between the two planes. Angle between the two planes is same as angle between their normals. Angle between the two planes is same as angle between their normals. Now if I take like this one plane, I take r bar dot m1 is equal to q1, r bar dot m2 bar is equal to q2. Definition says angle between two planes r bar dot m1 bar is equal to q1, r bar dot m2 bar is equal to q2. The angle between two planes r bar dot m1 bar is equal to q1, r bar dot m2 bar is equal to q2 is same as angle between their normals, that is m1 comma m2. So therefore, cos theta is equal to, I can take m1 bar dot m2 bar by modulus of m1 bar into modulus of m2 bar. You can very well observe, as we have proved, the vector equation of a plane in which p be the perpendicular distance from the origin and n cap be the what? Unit vector perpendicular to it, is given by r bar dot n cap is equal to what? P. Here n cap is nothing but a what? Normal. So therefore, in place of n cap we have m1 bar, and what? In place of n2 cap we have what? m2 bar. Nevertheless, m1 bar and m2 bar are the what? Normals. So therefore, the angle between the two planes is same as angle between their what? Normals. Angle between the two planes is same as angle between their normals, is given by that is cos theta is equal to m1 bar dot m2 bar by modulus of m1 into modulus of what? m2. So therefore, we come across how to find out the what? Angle between the two planes. Okay, I give one example. What's the example? Example is, right, let r bar dot of I plus j plus k is equal to 1, r bar dot of 2i minus 3j plus 4k is equal to 2, right? Is equal to 2. Represents two planes. Represents two planes. Then angle between two planes is dash. Now what I do is, he has given the solution of this one is, it is given r bar dot m1 bar is equal to what? q1. So therefore r bar dot m2 bar is equal to what? q2. Given two planes are in this form, it is quite obvious q1 is equal to 1, q2 is equal to 2. m1 bar is equal to I plus j plus k, and m2 bar is equal to 2i minus 3j plus 4k. So therefore, now coming this one is 4k. Now let us see what is m1 bar dot m2 bar. First you find out. Now this becomes 2 minus 3. It's a plus. Now it's a plus 4. So therefore it's a 1. It's a what? 2 rather. It's a 2. And meanwhile, what is modulus of m1 bar? Modulus of m1 bar is equal to root 3. And modulus of m2 bar is equal to how much? 4 plus now 16, 20. Therefore it's what? 29. Now yes, dot product is not a 0. So therefore directly I will go for what? Cos theta is equal to m1 bar dot m2 bar by modulus of m1 bar modulus of m2 bar. Now this is nothing but m1 bar dot m2 bar. m1 dot m2 already found out by 2. This is nothing but root 3 into what? Root 29. So therefore this is nothing but I can write theta is equal to cos inverse of s, 2 by s, root 3 into root 29 is the angle between the what? Two planes is same as angle between their what? Normals. And always you must be very cautious. Whatever the cos theta value you are getting, it must be less than 1, because it value lies between what? Minus 1 to 1. So therefore it must be always less than or equal to 1. Yes. Now that is something 2 by, it is always what? Less than 1. It is quite obvious. So therefore now the angle between the two planes is cos inverse of 2 by root 3 into square root of what? 29. Next, now in another form I take, say for example, I will write another example. Let us discuss in detail about this. Now let that is 2x plus 3y minus z is equal to 4. Next I go for what? That is 5x plus 4y minus 8z is equal to 1. Represents two planes. Then angle between two normals is dash. Look here, students, as you know already, the angle between the what? Two planes is same as angle between the normals. There is no separate formula to find out angle between the what? Two planes. Same formula. But here, in comparison with this problem and this problem, one work is added to the what? The hands of the what? Students. What is that? Here, these given planes are directly in what form? R bar dot m1 bar is equal to q1. R bar dot m2 bar is equal to what? q2. R bar dot m1 bar is equal to q1. R bar dot m2 bar is equal to what? q2. So therefore directly here m1 is available, m2 is available. Directly you can go for finding the what? Cos theta is equal to m1 bar dot m2 bar by what? Modulus of m1 into modulus of m2. Modulus of m1 into modulus of m2. So therefore you can find out if m1 bar dot m2 is equal to what? 2. You substituted. Now here what you do, here it is not m1 bar and m2 bar are not available. Then what you have to do, the given planes are in Cartesian form. Given planes are in what? Cartesian form. So therefore when they are in Cartesian form, so you have to extract what is m1 and what is m2. How to extract? m1 is rather coefficients of xyz. Meanwhile, m2 bar is also coefficients of what? xyz. That constitutes m1 bar and m2 bar. So therefore, I can write the solution of this one is, m1 bar is equal to, what's the quotient of x? This is 2, it's a 3, it's a -1, means he has taken dot product of this. Always m1 bar may change, m2 bar may change according to the scalar components, but r bar is always according to orthogonal coagulous coordinate system. R bar is equal to xi plus yj plus what? zk. So therefore, now this is now m2 bar is equal to the coefficients of now xyz. I can write 5, 4, -8. So therefore, take, now I can write, so the angle between two planes is equal to angle between their normals. Therefore, cos theta is equal to m1 bar dot m2 bar by modulus of m1 into modulus of m2. Take the dot product. 2 into 5, 10. 3 into 4, 12. Plus 8. Whole divided by, now this is square root of, how much it is? 4 plus 1, 5. 5 plus 9, it's a 14. Now this is 25 plus 16 plus 64. 64 plus 16, 80. This is 25. So therefore, this becomes 105. Therefore, this is the angle between the what? Two planes. Yes, students, we come across now the angle between the two planes is same as angle between their what? Normals. Angle between the two planes is same as angle between the normals. The planes may be of any type. The planes may be r bar dot m bar is equal to q1, or r bar minus a bar dot what? N cap is equal to what? 0. I mean, so it may be passing to the point A, that may be not passing to the point A. Any type of plane may be, the angle between the two planes is same as angle between their what? Normals. Followed? Right. Now, look here. Coming to this one is, now let us discuss about, after knowing this one is, some important geometrical approach on special problems about the what? Angle between the what? Two planes. Now comes about angle between a line and a plane. So remember, the angle between line and a plane. Then you see, let r bar dot m bar represents plane. R bar dot m bar is equal to P, and r bar is equal to a bar plus tb bar represents plane and a line respectively. Then angle between the plane and a line is equal to the complement of the angle between two planes or two lines also. Between two lines it doesn't changes. Between the two planes it won't change. If it what come on line and a plane, it comes as what 90 minus theta complement angle. So therefore now complement of angle between the two planes, which implies now cos of 90 minus theta. This is a position vector of a point. You should not take into consideration this is a vector, this is also a vector. This is a line passing through the point A bar and parallel to what vector? B bar. So therefore I will write this one as cos of 90 minus theta is equal to, yes, now I can write m bar dot p bar by modulus of m into modulus of b bar, which implies sin theta is equal to m bar dot b bar by modulus of m bar into modulus of b bar. Theta is equal to sin inverse of m bar dot b bar by modulus of m bar modulus of b bar. This is the angle between line and a plane. Angle between line and a plane. Now by using the concept of what? Angle between the two planes, angle between the two lines, angle between line and a what plane, let us discuss about some special problems of geometrical applications. Right. The vector equation of a sphere. The vector equation of a sphere. Now look here, sphere is a 3D concept, circle is a 2D concept. Now here also let S be a sphere, and C be a fixed point in a space, and P be the moving point such that the distance from the point P to the C remains constant. Then the locus of P is called what? Sphere. With that concept, I want to find out the equation of a sphere having the center C, whose position vector is what? C bar, and radius A units. Okay, let us see. After knowing the definition of a locus, now I'll find out the equation of a sphere. What's the theorem says? Equation of a sphere having the center C, whose position vector is C bar, and the radius is A units, then is modulus of R bar minus C bar is equal to A. Is what? A. Let us take, this is O of origin. Why? It's a position vector C of C bar. This is position vector C bar, and position vector is what? R bar. This length is what? A. Now I start like this. The proof of this simple is very simple. Let let P of r bar be a point on the sphere. Yes. So, and sphere, and C is the center whose position vector is C bar such that OP bar is equal to R bar, OC bar is equal to C bar, and the radius is A, which implies CP bar, modulus of CP bar is equal to A, which implies is equal to A, which implies is equal to A. This is the equation of a sphere having the center C of C bar and radius A units, So therefore I can write radius A units. Now if I square on both sides, R bar minus C bar whole square is equal to A square, which implies R bar square C bar square minus 2 into R dot C is equal to A square. This is also one way of writing the what? Equation of sphere. The another one also I can write. What is that? R bar square minus 2 into R dot C is equal to A square minus C square. This also represents the equation of a sphere. The equation of a sphere having the center C of C bar and the radius A units. Remember, the equation of a sphere with center C and radius R is maybe R modulus of R bar minus C bar is equal to A, or R square R bar square plus C bar square minus 2 into R dot C is equal to A square. C square R square has nothing but about scalars. If you square the what any vector, it becomes what? Scalar. Now R square minus 2R bar dot C bar is equal to A square minus what? C square. This represents the equation of a sphere. Let us see how to write the Cartesian equation of a plane. Cartesian equation of a plane. This is vector equation of a what? Sphere. Right. Now coming to the Cartesian equation of a plane. Listen students, I want the Cartesian equation of a plane having center C bar is equal to x1, y1, z1, C bar, and radius A is x minus x1 whole square, y minus y1 whole square, z minus z1 whole square is equal to A square. x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square is equal to a square. How it is? Let us see. As you know already, this is a sphere origin. If I take this what, come on, if I take this as a center, this is C of C bar, P of R bar, this is a radius, this is C bar, this is what, come on, R bar. Yes, according to this, the proof is very simple. The vector equation of a sphere, vector equation of a sphere having the center C of C bar and radius A is modulus of C bar minus A bar is equal to A. Now put R bar is equal to xi plus yj plus zk. C bar is equal to C1i, C2j, C3k. Followed? Not instead of C2, you take as x1, it's a y1, z1 is, then 1 implies in 1 implies xi yj minus x1i y1j z1k is equal to A. Group the what similar terms, x minus x1 into I, y minus y1 into z, z1 into k is equal to A. Take the modulus, which implies x minus x1 y minus y1 whole square is equal to A. Squaring on both sides, which implies this is the what? Equation of a sphere. Remember, if the center is 0, 0, if the center is 0, 0, note, if center is equal to 0, 0, this is you call it as 2. Okay, 2 implies right. This represents the Cartesian equation of a sphere having the center x1, y1, z1 is given by x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square is equal to what? A square. What is the Cartesian equation of a plane having the radius A is given by x square plus y square plus z square is equal to A square. These are the Cartesian equation of a plane, the Cartesian equation of a sphere having the center x1, y1, z1 and having the center what? 0, 0. Meanwhile, the radius is what? A units. Okay, let us see the equation of another sphere, right? Now, let us recall the concepts of sphere for giving some examples on that. Now, I want to find out the example on this equation of a sphere. Equation of sphere having the center C of 1I plus 2j plus 3k and radius 5 units is dash. I'll go for the solution of this one is equation of sphere having the center C of C bar is equal to, that is C of I plus 2j plus 3k and radius A is equal to 5. A is modulus of R bar minus C bar is equal to A, which implies minus I minus 2j minus 3k is equal to 5 units. This represents the vector equation of a sphere having the center with position vectors I plus 2j plus 3k and radius A is equal to 5 units. Followed? Right. Now, I want to find out the equation of a sphere, Cartesian equation of a sphere having the center and radius something. So therefore, if I go for center C, center first one is 2, 4, 5. The second one is 0, 0 and radius 5 units is dash. I'll go for first one is the Cartesian equation of a plane, equation of sphere having the center C of x1 y1 z1 and radius A is x minus x1 whole square, y minus y1 whole square, z minus z1 whole square is equal to s square. X minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square is equal to s square. Come on, take this point as x1 y1 z1. Come on, substitute. This implies x minus 2 whole square, y minus 4 whole square is equal to z minus 5 whole square, 25. This represents the Cartesian equation of a sphere having the center 2, 4, 5 and radius 5 units. Followed. Next, in detail, let us recall the concept, same concept, equation of a sphere having the what center's origin. So therefore, now equation of sphere, the second one is the Cartesian equation of a sphere having the center 0, 0 and radius A is x square plus y square plus z square is equal to a square, which implies this is the Cartesian equation of a sphere having the center 0, 0 and radius 5. Right. Now, since a sphere is a 3D concept, in circles we know that the angle in a semicircle is what? 90 degrees. In sphere also we can go for it. So therefore, no, the angle in a semicircle is what? 90 degrees. Similarly, the angle in a what? Semisphere is also what? 90 degrees. I want to find out the equation of a sphere having A of A bar and B of B bar as the extreme ends of the diameter. As the ends of a what? Diameter. So therefore, now what I do is, you take this is the circle. You take this circle. This is A of A bar. This is what? B of B bar. B of B bar. So therefore, now if I take a what point? P of R bar. This is the angle in a semisphere is what? 90 degrees. If A of A bar, B of B bar represents a what? Ends of the diameter, then midpoint of the diameter is the center of a circle. So therefore, what I do is, I want to find out the equation of a sphere. I go for the theorem. What is that? Equation of a sphere. Equation of a sphere having A of A bar, comma B of B bar as ends of a diameter is R bar minus A bar dot R bar minus B bar is equal to 0. R bar minus A bar dot R bar minus B bar is equal to 0. So therefore, I want to find out the equation of sphere in this way. I start, the proof of this one is very simple. Let A of A bar, B of B bar be the ends of a diameter. Let P of R bar be a point on the sphere where OA bar is equal to A bar, OB bar is equal to B bar, be the position vectors. Position vectors, by definition, the angle in a semisphere is what? 90 degrees. PA bar dot PB bar is equal to 0. Why? The angle between these two vectors is what? 90 degrees. The dot product is equal to what? 0. The dot product is equal to 0. So therefore, PA bar dot PB bar is equal to 0, which implies what is PA bar? PA bar is equal to, I can write OP bar minus OA bar dot OP bar minus OB bar is equal to 0, which implies r bar minus a bar, r bar minus b bar is equal to 0. So therefore, this represents the vector equation of a sphere having a bar and b bar as ends of the diameter. Ends of the diameter. Yes, if this represents the equation of sphere having a bar and b bar as ends of the diameter, then what is the position vector of a what center? We know that since C is the center, C is the center of a sphere and is midpoint of AB, which implies, come on, OC bar is equal to OA bar plus OB bar by 2. Therefore, OC bar is equal to is the position vector of a what? Center, is the position vector of the center of a sphere where a bar and b bar are what? Ends of a diameter. Right? Thank you.